And I'm very pleased to have on the line with us Dr. Michael Mann, Distinguished Professor of Meteorology and Director of the Earth System Science Center at Penn State University, author of the new book, The Madhouse Effect, or co-author, The Madhouse Effect, How Climate Change Denial is Threatening Our Planet, Destroying Our Politics, and Driving Us Crazy. His website, Michael Mann, it's MANN.net, and you can tweet him at Michael E. Mann or at Penn_State. And Dr. Mann, welcome back to the program.
Thanks, Tom. Always good to be with you.
It is a pleasure and honor always to have you with us. What is the current state of knowledge about what's going on with global warming?
Well, there's no debate at all within the scientific community that climate change is real, that it's human-caused, and that it's already having negative impacts. The impacts will be much worse if we don't do something about the problem. So there's literally no debate within the scientific community, despite the fact that the public discourse over this issue often it takes the form of what appears to be a contentious debate where there in reality is none.
Right. And I guess the larger question I was asking is, I see this note, Earth is warming at a pace that is unprecedented for the past 1,000 years, according to NASA scientists. Where are we at in this spectrum of climate change from, minor inconvenience to absolute screaming disaster? And how long do we have? I mean, you understand the question.
Yeah, it's interesting, that latest headline, I saw that in The Guardian. As dramatic as it might sound, that's actually not a new finding. It literally dates back 2 decades.
Wow.
Our early work, in fact, the so-called hockey stick curve that my co-authors and I published back in the late 1990s, showed that the recent warming is unprecedented in at least 1,000 years. And the evidence has just become more and more overwhelming over time. Many other groups have weighed in with their own analyses. Some of these analyses actually suggest that the rate of warming we're seeing now has no precedent as far back as we can confidently go, which is tens of thousands of years right now. So we are in the midst of an unprecedented change in our climate, warming of the planet, and all the associated effects of that: melting ice, rising sea level, worsened drought in many regions, worsened flooding in other regions. And yet this is the proverbial tip of the iceberg, because we will see far more dramatic additional changes in the climate, far more warming of the planet, the potential loss of much of the Greenland and the West Antarctic ice sheet, enough to give us 14, 15, 16, 20 feet of sea level rise. We could see those sorts of changes within the next century or so, and many of those worst impacts emerging just within the next decade or so if we continue on the course that we're on. The good news is that there is still time to change course.
So I had a conversation a week or so ago with Dr. Charles Miller of NASA, the CARVE experiment. You're familiar with it, I'm sure. And he said that when we talked to him a couple of years ago, he was like, we're trying to figure out exactly how much carbon is in the Arctic region. And he said, we pretty much got this nailed down now, or we're getting close to it, and that there was 10,000 billion tons of carbon, mostly in the form of methane hydrates, just in the Arctic Sea. What does that mean? I mean, there's a cruise ship going through that sea as we speak, which has never happened before.
Yeah, I mean, that's an example of the unprecedented changes that we are seeing, where the mythical Northwest Passage is no longer mythical. Ships can now navigate the Arctic Ocean because of the dramatic loss of sea ice, which, by the way, is more dramatic than what the models had predicted just a decade ago or so. Just as the melting of the ice sheets is happening faster than the models predicted. This is unfortunately a recurring theme where, though my colleagues and I have been labeled alarmists by the critics, if anything, we've underestimated the impacts and the changes that are already afoot. Now, as you allude to, there's the potential for surprises, so-called surprises, not good surprises. These are pretty nasty surprises that loom in the future. If we continue to burn carbon, warm the planet, we could potentially melt the permafrost in the Arctic enough to mobilize much of that methane that you refer to, much of that carbon that's currently frozen in the Arctic permafrost. We know that it was in the atmosphere in the past when conditions warmed similarly to the way that they're warming now. And so there's the danger we could add a whole bunch more carbon to the atmosphere. Here's the bottom line. The Earth had concentrations of CO2 in its atmosphere that were several times larger than what they were today back in the early Cretaceous period when dinosaurs were roaming the planet. Now, those CO2 levels came down naturally over the last 100 million years. What we're doing now by mining all of these fossil fuels and burning them is literally taking all that carbon that nature buried over 100 million years, and we're returning it to the atmosphere 1,000,000 times faster over a time scale of less than 100 years. That is the profound nature of this dangerous experiment that we are playing.
So what do we do?
The good news, is that we're starting to see some signs of turning the corner with our carbon emissions, for example. Global carbon emissions, for the first time on record, actually decreased slightly, almost within the statistical noise, but they did decrease slightly over the last year, which suggests that efforts by countries around the world, including the U.S., to get off carbon, get off fossil fuels, incentivize renewable energy, wind, solar, geothermal, electric vehicles, all those efforts that we see taking place here in the U.S., that we see taking place elsewhere around the world, where they're, in Europe, in particular in Germany, there's been a massive transition away from the burning of fossil fuels towards the use of renewable energy. Those efforts are showing dividends already. They're showing up in the global numbers. We see those carbon emissions coming to a peak. Here's the challenge. Just bringing them to a peak isn't enough. As long as we continue to emit, even at current levels, we will cross that threshold of dangerous interference with the climate in a decade or less. What we need to do is turn the corner even faster, bring those emissions down dramatically in the years ahead.
Yeah, and is in your opinion, is a carbon tax the best way to do that?
Well, I try not to weigh in too prescriptive a manner when it comes to those sorts of decisions, carbon tax versus cap and trade versus other vehicles. You have in Europe, for example, they use feed-in tariffs to incentivize renewable energy, which is another way to try to level the market, the energy marketplace, so that non-carbon energy can compete fairly against fossil fuels. Right. There are many different ways for doing this. Let's debate that. Let that be the debate among our politicians. That's a worthy debate.
Yeah, time for a policy debate, because the science is done. It's cooked. We know what's going on. Dr. Michael Mann, you are brilliant, sir. Thank you so much for dropping by today.
Thank you, Thom.
And let me plug your new book. It's called The Madhouse Effect. Check it out. Thank you, Dr. Mann.